Now let's quickly write the C++ logic for arranging coins problem that we are discussing. Here I have defined the function declaration, right? As part of the first step, what I want to do is, if at all the total number of coins that I have got is less than or equal to 0, and the number of steps that we can arrange with those coins will be 0 itself. So I'm simply going to return 0. If this is not the case, in that case we will simply use binary searching for finding what is the last step that has successfully arranged all the coins whatever we have got. So here for that, let's just define start and initialize it with 0. This start will basically represent the starting step. Similarly, to represent the ending or the last step, I'm going to define one with end, and this will be is equal to coins. Along with that, to represent the middle step, I'm going to define one variable middle and initialize it with -1. Now let's just run a loop as long as this start is less than or equal to end. Here what I want to do is, first let's just calculate the middle step. That middle step is nothing but start plus end divided by 2. Once we calculate the middle step, the next step would basically require what are the total number of coins that are consumed till that middle step. And the problem statement clearly mentioned that for any ith step we would need I number of coins for arranging. So till this middle step, the total number of coins consumed will be, middle into middle plus 1 divided by 2. So here let's just define one variable, total coins is equal to middle into middle plus 1 divided by 2. This is nothing but sum of natural numbers formula, because first step will consume 1 coin, second step will consume 2 coins, third step will consume 3 coins, fourth step will consume 4 coins, like that, right? So till middle step, the total number of coins consumed will be 1 plus 2 plus 3 plus till middle. That is nothing but sum of natural numbers. That natural number here is nothing but middle, right? So middle into middle plus 1 by 2. So here, if at all the total coins that we have consumed till that middle step is equal to the coins that we have been given, so that is the step that we can arrange all the coins till. So here we will simply return middle itself. Okay, if this is not the case, what if the total coins that we need till that middle step is greater than whatever we have? Okay, so the coins that we would be needing till the middle step that we have calculated is greater than what we have in hand. So the last step that we can fill will be till middle -1. So here, to continue that case, we will simply update end with middle -1. If this is not the case, then the total number of coins that we consumed till that middle step is less than the coins that we have. That means we still have some more coins that we can arrange the steps after middle. So to find the last step that we can successfully fill, what I will do is I will update the start with middle plus 1, so that we will proceed with this logic and find the last step. Now here, this condition will basically match if at all the coins that we have and whatever the coins consumed till middle are matching, and we can simply return middle itself. But if at all, if it is not matching, we would still remain certain number of coins and we would arrange it on the next step also, right? That next step, basically the last step that we need to return in the end. So that last step, once we complete this while loop, that last step, whatever we have filled successfully, will be available inside this end variable. So we can return that end, which basically represents till that step we have successfully filled all the coins and there were some more coins that were left, and we have filled end plus 1 step. But the coins are arranged or filled till end step completely. Okay, so that is what it is. Okay, so that is the implementation of the solution using binary searching technique. So here I have written the code for calling that function also. Now let's just try to test the scenarios. So the number of coins that I have given here are 10. So first step will consume 1, second step will consume 2, and the third step will consume 3, and the fourth step will consume 4. So 4 plus 3 plus 2 plus 1, which is nothing but 10. So if I run this code right now, the number of steps that I can arrange the coins that I have got will be 4 steps. So the output is 4. Let's just say here I have given only 9 coins. So till third step we have consumed 6 coins. For the fourth step we need 4 more coins, but we have only 3 left. So fourth step we are not able to fill or arrange completely. So the output should be 3, because till third step we have basically filled or arranged each and every step perfectly. So that is what we have got here. Okay, you can pass any value and whatever the logic that we have written works. If I pass only 1 coin, and that 1 coin can be used for arranging on the very first step, right? So the output should be 1, and that is what we have got. Okay, if I pass any negative value also or 0 also, it will return 0 only, because technically the negative number of coins are not at all possible. Okay, so that is the solution for arranging the coins using binary searching technique.